So this question is find all k distinct indices in the array. So it's pretty confused. So you give an integer array and also a key and a k. So key represent the value you want to compare with the nums array, and then k represent the range. So you want to find a k distinct index, so which is the range between the value that is, that equals to the num size. So let's look at this. So it's going to be k distinct index in is index I of nums, at least index 1 in the index j such that this constraint and this constraint. So in this case, so let's look at this. In this case, k key equal to 9. So 9 is right here, and then k equal to 1. So k equal to 1 is you want to get the range between here and here. So what you can do is you want to make sure you fulfill this constraint I minus j less than absolute less than k, and also nums j equal to key. So which is true, right? So this is why you want to take the indices. So 1, 2, 3, 4, 5, 6, right? So the next is going to be nums array equal to 2, key equal to 2, k equal to 2. So in this case, this is key, key, right? So if you want to say key, the range for the index 0 is from -2 to 2. But in this case, we don't have negative value, negative index, so we're starting from 0, right? And then when you move to this index 1, it's going to be this and this. So -1 right here, since there's no index -1, so it has to be what? Start from here to here, right? And then this would be the same thing. So make sure you don't out of bound. Don't go out of bound. So here's an example of the diagram. So basically that's straightforward. When key equal to 9, so it's point at here. The k equal to 1, so it's a range between key and then the k. So I'm gonna say range. So right here and also right here. And then if I take the comparison, the constraint, which is valid, then you're going to assign the index. So let's look at this. If the key equal to 4 and then the first value equal to 4, we don't want to go all bound, right? So we want to make sure we start in index 0 all the way to the 2. And then same thing for the the last few value. We don't want to go all bound, right? And then we want to avoid the overlap. So once you traverse from the beginning, if a key equal to 3 right here, you want to make sure your j pointer, so this is the range, right? The range represents the j pointer, and then the blue arrow represents the I pointer. You want to make sure your j pointer is increasing, not decreasing, and then j shouldn't be reset because you're going to add based on j, right? So let's dive into the solution, and then you will see. So you need to return list of integer, right? You read this, return result, and then you need to have it in I equal to 0 and j also starting from 0, right? And all the way to the end. Oh, and I plus plus. Cool. So so the constraint is straightforward. So if the nums I is equal to the key, this is the first scenario you want to compare, and then the second one is in j equal to math.max. So this is going to tell you I don't want to go all bound in the beginning. So it's either j or I minus k, right? So this the left side. Think about the left side, and then the right side is going to be what? J less than equal to I plus k, right? But also we don't want to go all abound, so j less than num star length, and then j plus plus. So once j is increasing, we only initialize this once. Actually, we don't need this. So once j is initialized in here, we always increasing, and we never reverse, right? We never go back to the previous index. So once this happening, then just add the j. J is the thing we need to add. I is not um, the index we need to add is j. So let's just run it. Submit. All right. So time and space is all of n. Time, this is all of n, and this is all of n. So it's consider n square. So because if a k is what? If a k is cover all of the all of the value, you still need to traverse the inner array again, right? So it should be n squared for the time. Space is all of n. Alright, see you later. Bye.